Sony has recently announced a 247 megapixel medium format sensor, while Nikon is venturing into 1000 frames per second video capabilities. These groundbreaking advancements mark a new era in imaging technology, promising fast and high-quality images that could redefine industry standards. Join us as we explore the potential implications of these exciting developments. Nikon has introduced a groundbreaking CMOS sensor at the International Solid-State Circuits Conference in San Francisco. This sensor features a 17.84 megapixels resolution in a unique square shape, measuring approximately 1 inch diagonally. It boasts high-speed readout capabilities, enabling 4K video capture at an impressive 1000 frames per second, placing it in direct competition with leading cameras like the Phantom Flex 4K. Despite the high frame rate, the sensor maintains an outstanding wide dynamic range of 110 decibels at 1000 FPS, which jumps to 134 decibels at 60 FPS. This innovative sensor is protected under the Patent Image Sensor and Electronic Camera, filed in April 2021 and granted in December of the same year. Although the patent doesn't explicitly reference the 1000 FPS CMOS sensor, it is widely believed to be associated with it. The sensor stands out due to its unique square shape, hinting at potential applications in both industrial and consumer settings. With a 4K by 4K resolution and dimensions of approximately 25.4 by 25.4 mm, slightly larger than APS-C, this sensor quickly switches between horizontal and portrait orientations without physically adjusting the camera, simplifying rigging. Moreover, this sensor offers a wide dynamic range and a fast frame rate, allowing for vertical shooting without the need to rotate the camera. Compared to Sony's RX106, which features a 1-inch sensor capturing 960 FPS at 1244 by 420, Nikon's new 1-inch sensor can capture 1000 FPS video at 4K by 4K resolution. However, the duration for which the Nikon sensor can maintain this high frame rate is unknown. The new sensor design incorporates a back-illuminated layout, leveraging technology introduced by Sony in 2009. This layout enables light to reach the device's surface without metal wiring, enhancing sensitivity and benefiting high-speed cameras. Manufacturers are actively exploring the segregation of light-sensitive photodiodes and signal processing electronics onto separate layers to optimize performance. While it remains uncertain whether Nikon's design achieves this separation, it represents a potential step in that direction. The new sensor facilitates high frame rate video capture at high resolution and supports HDR imaging. It has been engineered to achieve an exceptionally high dynamic range using 2 layers. Unlike conventional sensors, this innovative design adjusts the exposure of individual blocks separately to capture a broader dynamic range. It employs a sophisticated process to handle overexposed and underexposed areas in the image. Integrating 2 image sensors on top of each other effectively creates a 256 by 256 superpixel array. This groundbreaking concept enables more fabulous light capture in areas that require it and reduced light in overly bright areas. However, further assessment is necessary to determine the output quality, visibility of superpixel exposure chunks in the image, limitations of its capabilities, and potential post-processing possibilities. The new sensor, featuring a square capture area, is well suited for circular fisheye lenses used in dual-lens 360 cameras. Nevertheless, its large size may restrict the number of companies capable of utilizing it. Only Ricoh has successfully employed a 1-inch sensor for its flagship 360 camera, the Theta Zone. If a 360 camera can integrate 2 of the Nikon sensors, it could achieve a video resolution of 5.7K at 1000 FPS, marking a significant milestone in the 360 camera industry. It is more probable that such a sensor will find applications in industrial settings before reaching the consumer market. Square sensors may eventually gain popularity, particularly their ability to capture frames, allowing horizontal or vertical cropping in post-processing. However, whether Nikon will lead this development remains uncertain, as they are no longer considered pioneers in the consumer camera industry. Nikon has yet to announce which camera will use this sensor. Heat and data management challenges may make it difficult to use a consumer camera. The sensor can adjust the readout time across small pixel blocks, affecting traditional photography and requiring careful post-processing. Demo images show the sensor's extra high dynamic range behavior but lack detail. If advancements make it more affordable, it could address previous limitations, which would be a big deal. Meanwhile, Sony Semiconductor Solutions has unveiled its latest innovation, a 247-megapixel medium-format sensor. This cutting-edge sensor, designated as the IMX811AAMR and IMX811AAQR, is remarkable for its resolution and potential applications. With dimensions comparable to existing 100 and 150 megapixel sensors found in high-end cameras like the Phase 1 IQ4 and Hasselblad H6D series, this new offering is set to redefine the standards for image quality in various sectors, particularly industrial imaging. The sensor designated as IMX811 boasts an impressive resolution of 247.4 million effective pixels, resulting in an image size of 19,200 by 12,800 pixels at a 3:2 aspect ratio. Measuring 53.96 mm by 35.97 mm, this back-illuminated medium-format sensor is engineered to optimize light capture, enhancing image quality and detail. It is available in color and monochrome variants to accommodate diverse imaging requirements. With a maximum output speed of 3 frames per second in all-pixel readout mode, the sensor excels at high-speed photography without compromising on detail. Moreover, it is equipped with a 16-bit analog-to-digital converter, enabling high dynamic range imaging, and offers a maximum gain of 24 decibels to adapt to varying lighting conditions. The unit cell size of 2.81 by 2.81 microns underscores its advanced capabilities, making the IMX811 sensor suitable for various industrial and potential consumer applications. The current positioning of the IMX811 for industrial use has sparked interest in its potential application in consumer photography. Historically, sensors designated initially for industrial purposes have been integrated into mainstream camera systems. For instance, the IMX461 sensor, initially intended for industrial use, is now incorporated in the Fujifilm GFX100 and the Hasselblad X series. This historical precedent leads to optimism regarding the possibility of the IMX811 making a similar transition to consumer-grade cameras, thereby enhancing the photography realm with its exceptional resolution capabilities. This sensor's high-resolution imaging capabilities open up many potential applications. Professional photographers in specialized fields such as architecture, fashion, and product photography could use this technology to capture previously unattainable details. It could also be used in industrial contexts for precision tasks like quality control in manufacturing processes, where minute details are crucial for product success. The IMX811 has advanced processing capabilities. It can efficiently handle high dynamic range images, making it great for photographers and professionals who work in challenging lighting conditions. Its back-illuminated structure maximizes light intake, which is essential for capturing high-quality images in low-light environments. The built-in 24 decibels PGA circuit further improves its performance, offering flexibility for different conditions and applications. Additionally, the IMX811 supports different readout modes, including rolling shutter functions, for adapting to various shooting scenarios. Sony's track record of adapting its sensor technology for various markets is encouraging. The company has a history of integrating features initially designed for industrial or scientific use into consumer products. If the IMX811 is integrated into a consumer camera, it could have a profound impact, ushering in a new era of ultra-high-resolution photography. The initial announcement highlights the industrial applications of the IMX811, but the potential for consumer adoption is significant. Many photographers are excited about more accessible access to high-resolution sensors. Camera manufacturers are working with sensor manufacturers to develop new medium-format cameras that use this technology. The highly anticipated IMX811 sensor has generated significant interest within the photography community, prompting calls for Sony to explore its potential for consumer applications. The demand is rising for a high-quality fixed-lens RX camera with an advanced sensor promising excellent detail and range in a small size. This camera type would be popular among professional photographers and enthusiasts seeking a powerful tool for their creative ideas. While currently designed for industrial use, many in the photography community hope this innovative sensor will be used in consumer cameras, potentially redefining photographic precision and quality for industrial and artistic projects. Thank you for watching. The competition between Nikon and Sony is driving innovations in cameras. Nikon is working on creating high-speed videos, while Sony is focused on achieving high resolution in their photos. This competition will result in new and improved cameras, changing how we take pictures and videos. We look forward to hearing more from you as well.